All right, time for the crash course review on your rigid transformations. You guys remember rigid transformations? It's been a minute or two. So some of these are going to be a little bit difficult to do on the computer, but we're going to do our best, okay? Now remember, the word rigid transformation means that the size and shape of these shapes does not change. The angles don't change. The side lengths don't change. That's it. The angles and side lengths don't change. This lightning bolt will still be a lightning bolt, and it will be the same size. We're not dilating this. It's not shrinking. It's not growing. It's not changing size, shape, or anything, but a translation. Okay. So we're going to look at what happens when we translate this lightning bolt along this vector. Now, remember, a vector tells us how far to move something, and it tells us what direction to move it in, okay? So when I translate this, I'm going to get a new one. This is lightning bolt. The first one is lightning bolt, right? And it is right there. And then the second one, I just move it along this vector to the end of the vector. And then boom, I drop it. This is lightning bolt. This is lightning bolt prime. It's not the same shape because the first one's still there, but it's a new shape in a new place, but it's exactly the same. We translated it. The size didn't change. The color didn't change. The orientation didn't change. The angles didn't change. Nothing changed except for the location of this lightning bolt in space. I could make another vector right here and translate it along that vector. Oops. Translate it along that vector, right? Let me get my pointer out, paste. So now we're up here, we're gonna translate it along this vector and end up right, the vector takes us this way, right? Boom, there, right? So, and that would be lightning bolt double prime because we've moved it twice now, but we can take vectors all over the place. Now, the thing is sometimes, ooh, check it out, it's right there. Sometimes we're going to be asked to do a translation on the coordinate plane. And so let's show you how that is done because the coordinate plane kind of really makes it easier. So let's say we have a vector. We're taking it, so this one takes us down. Let's count 1, 2, 3, 4, down 4, and to the right 2. So let's select on our shape. We're going to copy it and paste it so we can move it and compare where it was. So we're going to move it down 4. So this is now, before, remember when we were doing them by hand, we had to measure and use the stuff and it took forever. It's really easy on the coordinate plane. I just start here at the top of my vector is right here. I go 1, 2, 3, 4 down to the left 2. So I'm going to go 1, 2, 3, 4 down and to the left 2. And that's where my shape's going to be. So if my point, let's say this is point A. Let's pretend that this is point A, right? And point A is at -3, 2, right? -3, 2. Ooh, dear me, let's fix that. Then A prime, I've gone down 4 to the left 2. So now A prime is going to be at -2, -5. So A prime is at -2, -5, and it's really, really easy to see where it is. I just moved it down to the left. Again, size didn't shape, size didn't shape. Size didn't change, shape didn't change. It's a rigid transformation. None of that changed. Color didn't change, nothing changes. I don't know if color could change in a rigid transformation. We haven't really discussed that, but definitely size and shape do not change. Okay. Rotations. Now, rotations are the ones that are a little bit tricky to do on the computer because I can only rotate around a point in the center. Usually when we do a rotation, right, we rotate around some point like over here, right? And we're going to rotate it around that point. It's going to go this way or this way. But on the rigid transfer on the computer, I can really kind of only rotate it around the middle, right? So I'm rotating it around the middle. Now my point just happens to be in the middle on this one. But let's look at this. Does the size change? No. Do the angles change? No. It is a rigid transformation. So size doesn't change, angles don't change, nothing changes except for, in this case, it's the orientation now. And if we're rotating around this point, it would go like this and like this at the same time. Okay, so we could rotate it that way. Okay, let's look at this shape. Let's look at it on the coordinate plane. There's a nifty thing. When we rotate 180 degrees around the origin, kind of a cool thing happens. So what happens is the signs on the X's and Y coordinates change. So here we have the point -7,8, right? Right here. Let me make a little text box. So here we have the point -7,8. It becomes the point down here when we rotate it 180 degrees around the axis. Instead of being -7,8, it becomes +7, -8. So just the X value, the X value and the Y value both change their orientation. And my thing jumped. So, okay, there we go. So you can see what was -7 is now +7, and what was 8 is now -8. So that is something that you're almost guaranteed going to see on the ISAT, is that the values, the signs on the X's and Y coordinates will reverse. So if it was negative, it's now positive. If it was positive, it's now negative. When we rotate it 180 degrees around the origin. Okay, so now let's do some reflections. Now you always have to reflect over a line, and this is kind of your mirror, and you are reflecting it. You're going to see where the image is going to be around your mirror. So I'm going to copy it and I'm going to paste it on top of itself so we can see what happens. And then I'm going to reflect it over this. We're going to be the exact same distance in the exact same place. So it's in the same distance. It should be, if you did it right, the same distance from that line. And then again, it's a rigid transformation. So angles don't change, size doesn't change. None of the qualities of the shape change, except its location and its orientation. It is a mirror image of itself. So like if I have some text here, let's make it big. Let's say I have a giant letter B, right? And then I copy it and I paste it on top of itself. We're going to do the exact same thing that we just did. And then I'm going to it's not doing it for me. If I flip it, oh, maybe it's vertically that I need to do. There we go. And you can see, oh no, that was a vertical flip. Either way, okay, so it ends up being the opposite direction. So the words it's just like in a mirror, the words get flipped. Now let's look at it on a coordinate plane. Now on a coordinate plane, you could be asked to reflect over any line. Let's say we're being asked to reflect over the y-axis. I'm going to do the over the line x equals 1. So we are reflecting over the line x equals 1. I'm going to make it purple so we can see it easily. Okay. So reflecting over the line x equals 1. And so we know it's going to be reflected. So I'm going to copy it and I'm going to paste it. And I know it's going to be reflected, right? But where is it going to end up? Where is this guy going to end up? So I'm just going to count. This is the great thing. I'm just going to count how far away is this corner. I'm going to call this corner A. How far away is A from this line of x equals 1? How far away is A from the line x equals 1? Well, A is 1, 2, 3, 4. So my new point needs to be 4, A prime needs to be 4 away from x equals 1. 1, 2, 3, 4. And it just was reflected. It wasn't rotated or translated. And so it just drops right there. And it kind of looks wrong because we really like to have things reflected over the y-axis, but sometimes they're going to be reflected over a different line. This one was reflected over the line x equals 1. What if we reflect it over the line x equals -3? Can we do that? If I can draw the line on x equals -3, we're going to make x equals -3. We're going to make it blue, and I'm actually going to make it a little bit thicker so we can see it a little more easily. Okay, so I'm going to do the same thing. I'm going to copy this. I'm going to paste it, and I'm going to reflect it. And then I need to see where to drop it. Oop, I didn't reflect it right. I reflected it horizontally and not vertically. So let's reflect it vertically. Flip it vertically, okay? And now if I look over here, A is 1, 2, 3, 4, 5 away from that line. So A prime is going to need to be 1, 2, 3, 4, 5, and it has fallen off of my graph, and that's okay. But you can see they're both the same distance from this line, and that's all that really matters. This one was flipped over a vertical line. This was reflected over a vertical line, and this one was reflected over a horizontal line, and you can see the different places that they end up. If you reflect something over the y-axis, and then you reflect it over the x-axis, that is the same thing as rotating it 180 degrees around the center. So there is your crash course on the rigid transformations, both on a regular thing and on the coordinate plane. Good luck. Let me know if you have any questions, and I will talk to you later. Bye.